Orbital mechanics, it's two masses going around each other. That's all it is. It's relatively simple.
Did he really say that?
Orbital dynamics, orbital mechanics. It's essentially variables that help define where a satellite or an object is, generally in relation to Earth.
So what we have, basically the terms most people are familiar with are LEO, low Earth orbit, geosynchronous transfer orbits, a geosynchronous orbit, high inclined orbits, you have MONIA orbits, which are essentially GTO orbits, but high inclined, and retrograde orbits. Yeah, that's rocket science.
It's rocket science, but it's not impossible. In our world, the key skill set is orbital mechanics. So you understand how things maneuver in space. I think you can pretty much understand what we do here.
We get to design trajectories to launch satellites into space.
So a trajectory is basically what you would call a flight plan. How we're going to get to the orbit that we want to be in.
There are so many examples of being creative with the trajectory. Performance can be utilized in many ways. It can be used for launch window management, expanding launch windows.
I'm a guidance engineer, so I work on setting up the software to make sure the rocket gets into the right orbit once it leaves the ground.
We want to make sure that when we get to orbit that we're not going to run into an active satellite or debris or the space station.
And then the trajectory people hand it over to us guidance folks.
So I'm trajectory.
And what we do is then we turn that optimal trajectory into the software parameters that need to go onto the rocket itself to fly that profile. Rockets, basically just a computer that has a lot of flame going out the back.
It's all a matter of launch date and time, and also trajectory and mission design.
Obviously the planets have to be aligned.
Well, there's math and science involved.
Activating your brain every single day is very fulfilling. It's never an easy job, but it's always a rewarding and fun to solve these kind of problems.
We have the capability to go outside of our solar system. That's huge to be able to come into work and be able to do that every day.
I always want to figure out how do things fly, looking at airplanes, looking at rockets.
By the time I was in the 7th grade, when the question came up, what do you want to be when you grow up? The answer was, I want to be an aerospace engineer.
When I was about 5 years old, my dad took me out one day and he pointed out up at the sky. You could see this little dot moving across the sky, and it was the space shuttle, and I thought that was just about the coolest thing I'd ever seen.
I spent a lot of time flying small model rockets. Most of those were suborbital, but some still might be stuck in trees.
I like to claim that I'm probably the least nerdy. However, I did go to space camp.
It's definitely a team sport, and I think that's part of the unique part of rocket launching and rocket designing.
I like coming in every day and knowing that I'm going to be helping launch people to the space station.
Nothing beats that.
It's like GPS. We launch those things, and without that, I'd get lost on my way to work.
3 words that describe the job that I do.
Awesome. Challenging, definitely.
Definitely challenging, fun, exciting.
Engaging.
That's a good question.
I would say the 3 words would be fulfilling, challenging, and a lot of fun.
Rockets, orbits, and
Fun, challenging. I think the other one is thought-provoking.
Challenging, exciting, but ultimately rewarding with the launch.
what's the third one? I mean, you can't beat rockets in orbits, right? What happens after that? Mission success.
I'm Jeremy Ralph, and I'm a trajectory design engineer.
I'm Mates Niedercich, and I'm a guidance engineer.
I am Mark Smith, and I'm a guidance and navigation engineer.
My name is Kurt Heyer, and I work in the mission design group.
I'm Caroline Kirk. I'm a trajectory engineer.
Does what we do here at ULA, and to know that we're doing it with the best team in the world is pretty exciting.
I think that's about it.
It's interesting to see how much is out there that is actually really high fidelity and really, very close to what we do. We didn't have things like Kerbal when I was a kid.